Title: Why are human babies so helpless? Human infants are astonishingly helpless. A foal learns to walk typically within an hour of its birth. Newborn giraffes manage to stand on their feet in under half an hour. Sea turtles emerge on a solitary beach and instinctively rush toward the sea, evading predators along the way. Conversely, a newborn human can't even support its own head. Leave a human infant alone for a short period, and it may not survive. Unable to walk, talk, feed itself, or adjust its body temperature adequately, for the first few months, a human baby barely comprehends its separation from its mother. From an evolutionary viewpoint, this seems like a poor design. Despite becoming Earth's most dominant species, builders of cities, flyers of airplanes, creators of nuclear arms, and explorers of other planets, the initial stage of human life is eerily more akin to a defenseless potato than an actual living creature. So, why do human babies rank among the weakest on the planet? The explanation begins with an evolutionary quandary so profound that nature had to hastily devise a workaround to ensure our survival. The issue at hand is our brain. The human brain is exceptionally large. In adults, it weighs about 3 pounds and utilizes roughly 20% of the body's energy, despite being only a small fraction of our overall mass. Compared to our primate relatives, our brains are disproportionately large. This feature enabled humans to master language, devising plans, crafting tools, and eventually forming civilizations. Yet, with this evolutionary gain came a significant challenge. Larger brains necessitate birth. For millions of years, our early ancestors navigated on 4 limbs. Their hip structure was akin to that of other apes, allowing births to occur without major difficulty. However, between 6 to 7 million years ago, our ancestors began to walk upright. This transformation radically altered the pelvis's shape. While a narrow, bowl-shaped pelvis benefits upright mobility and balance, it complicates the birthing process for offspring with sizable skulls. Known as the obstetric dilemma, this challenge occurred when evolution led to larger brains and narrower hips. Eventually, nature hit a stalemate. The baby's skull grew too large to traverse the birth canal safely. As a solution, human babies began entering the world much earlier. Unlike their animal counterparts, human infants are born extremely undeveloped, not in a medical sense of prematurity, but developmentally so. For instance, a foal shows readiness for immediate locomotion owing to extended in-womb development. In contrast, a human baby arrives with an immature brain. If they were to remain in utero until fully developed, pregnancies would stretch between 18 to 21 months, and by that time, birthing through the narrow hips would be virtually impossible. Nature thus struck a compromise: initiate birth earlier and let development continue post-birth. It sounds peculiar, yet it functions. Essentially, during their initial year, humans are like external fetuses. Major developmental milestones transpire outside the womb. This accounts for the extensive sleep required by newborns as their brains grow at a rapid pace, nearly doubling in size in the first year. Unlike numerous animals that are instilled with pre-programmed instincts, human infants are born highly adaptable, ready to develop after birth. This adaptability represents a significant evolutionary shift. While a deer knows instinctively how to stand and spiders can spin webs without instruction, humans depend on learning. Human brains, left intentionally unfinished, absorb environmental information post-birth: language, culture, social behaviors, tool usage, and survival strategies. In essence, we've exchanged instinct for a prolonged learning phase. Consequently, our childhoods are bizarrely long compared to other animals, with reliance lasting numerous years. In some hunter-gatherer societies, self-sufficiency isn't attained until the late teens. Purely from a survival perspective, it seems inefficient to nurture a being for over a decade, but humans prioritize adaptation over mere survival. This adaptability has proved overwhelmingly potent. While wolves from different continents exhibit similar behaviors, humans thrive in deserts, jungles, frozen tundras, vast metropolises, and remote islands, each demanding unique survival skills. This flexibility stems from the initially undeveloped brain of a defenseless child. However, such helplessness introduced another significant challenge: ensuring the infant's survival. Many beasts employ a straightforward strategy: maternal guarding until young ones fend for themselves. But human infants required relentless attention, challenging solitary maternal care paradigms. Human offspring demand nurturing beyond what's typical for other species. They cry, wake at night, can't cling onto fur as primates do, and require regular feeding. These exhaustive demands on caregivers might have fundamentally influenced human societal structures. Anthropologists observing hunter-gatherer groups uncovered distinctive human child-rearing methods: collaborative childcare, extended networks involving grandparents, siblings, fathers, aunts, uncles, cousins, and even non-related group members collectively raised children. Termed cooperative breeding, it results from the immense effort required to sustain human infants, unexpectedly turning caregiving into a collective endeavor. This cooperative nature possibly reshaped human psychological tendencies, fostering highly social and empathetic communities. Your expansive social brain partially owes itself to the incredible burden of a newborn. There's yet another curious aspect of babies: their cuteness. Although seemingly less scientific, it's central to our survival. In the 1940s, ethologist Konrad Lorenz introduced the baby schema theory. Babies possess distinctive features: big eyes, rounded cheeks, tiny noses, and sizable foreheads, designed biologically to stimulate nurturing instincts in adults. Even those indifferent to children generally react to infant faces. Evolution harnessed this appeal because, without it, the overwhelming fatigue from raising a baby might lead some parents to abandon them. Despite this evolutionary charm, parenting remains challenging, often subject to endless complaints. But here's what's truly fascinating: their vulnerability might be the very reason behind our intelligence. Initially, scientists posited intelligence led to prolonged childhoods, but recent research suggests the opposite: that extended childhoods breed intelligence. Longer durations spent learning rather than relying on instinct enable complex thought and behavior. Across years of play, human children engage in simulations, acquiring language skills, understanding social rules, forging cooperative skills, and experimenting with creativity and problem-solving. Human children's lengthy play essentially runs intricate simulations of the world inside their minds. While other animals engage in play, humans extend this to the utmost degree, tracing back to an evolutionary necessity framed millions of years ago. The enlarged brains and narrowed hips demanded that humans emerge as the most unfinished species at birth. Yet this fragility laid the foundation for incredible creativity and progress, spawning civilizations, breakthroughs in science, and creations spanning art and religion, all stemming from a species whose infants couldn't survive unaided overnight. In paradoxical absurdity, we're the dominant life form starting from extreme helplessness. But evolution didn't fail us. It furnished something deeply profound: the gift of time. Time for learning, adaptation, and evolving to become something unparalleled among Earth's creatures.